about the cloud computing, all the service layers, all the deployment layers, and then virtualization. And then I was given hints on like how Aneka cloud application platform, or the architecture of Aneka cloud application platform. Um, as you see this Aneka architecture, then we also have seen that Aneka daemon, what is the function of the Aneka daemon, and then we have seen some foundation services, and then programming models like task, thread, and map, reduce, and so on. In the last, I just shown only a programming exercise of thread programming model. But today we will go through task model, and tomorrow also I will take some examples on thread model and map reduce also as well, and then some of the typical use cases of research publications. I will try to explain the research publications, like how people have already have done. So considering this, in our lab, like in MIT ADT, we have the cluster of LAN connected machines. Just let me. So we have this kind of LAN connected machines with one master and others acting as a workers. And then as a part of developing systems, we have used other systems where we installed Visual Studio on that. And then we have the three things in our hand, which when any person wants to develop the applications, then he should need three things in hand. For example, let me just write over here. So whenever you want to develop an Aneka application, so first of all is that you need an Aneka SDK. So Aneka SDK is needed, and if you are developing either task program or thread program or map reduce program, then you require the corresponding SDKs. And secondly, what you need is Aneka conf file. What indicates is that Aneka conf file says about the developer, or when you submit an application, it contains the QoS and Aneka scheduler address. Aneka scheduler address. So these things are present in this conf file. The basic conf file, for example, it looks like this. Here I can show you a basic conf file. So sorry. So this is a conf file. So basically it has these are like some of the QoS or some kind of properties that you need to say Aneka, and here is the scheduler URI. So this talks about where is your master, and also then you will also provide the user credentials. There are also another things will come up in the task programming. For example, you want to store data at one point and then you have to use, so we will add that also in the here in the configuration file. So this is the configuration file, and here then so you have the configuration file with you. And then the third thing is that you should have the Visual Studio editor. This editor could be either 2000 Lightil or Site 2022 or so on. So and so these are the things which are needed for the developer. So coming to the this architecture and all, so we have all discussed about this one, that these machines will have the Aneka daemon, who will act as an provides an platform or environment for this Aneka containers to run. And also he will also give all the information about the CPU, memory, about all these machines to the Aneka Management Studio. So, and there is a scheduler whenever the developer he wants to develop the application. So he will use the Visual Studio SDK, and then will use submits to the Aneka scheduler. So Aneka scheduler will take these work units or the task. Normally the tasks are called as work units here. The work units are like kind of executable units, smallest executable units. And these executable units taken by the scheduler, and he will try to distribute on these worker nodes based on his scheduling policy. And also he has capable to scale these worker units based on his need. And also if you have given some constraints like time constraint, cost constraints, or some kind of other either extrinsic constraints, then scheduler will take that responsibility and see that based on the filtering, so that kind of thing. So he will distribute the workload to the different nodes. And this workload, when I say, it's kind of a job has a tasks, and each task is called as a work unit. So this is called as one job, which has a two work units here. So this is how like the overall the view, the overall the internal architecture of the Aneka seems to work, or Aneka components, you can say. Uh, so in this session, what I done was like, since even though you also have your cluster at MIT ADT, what you have to do is like you have to switch on the Aneka in the master machine, like not in the master machine. Basically, it is like the machine which is at the corner where we installed Aneka. So there we have to import that the configuration file, and then we have to start that. Means like we have to open the Aneka Management Studio. So for this today's session, is it like anybody is there in that lab, or like anybody is sitting in the lab, or like, or how it is like? Oh, okay, okay, okay. Cables, okay. Yeah, yeah. So that's why. Yeah, yes, sir. Like, even though, like, if you are sitting in the cabin, then probably, if that machine is switched on, and not only that machine, the whole lab machines are switched on, and then this Aneka just you need to import the configuration and switch on the Aneka there, and then from your cabin itself, like, you can able to submit the job workloads to that Aneka from your machines, or from. Yes, sir. Yes, sir. We need maybe uh, we need, I think that private IP should work. The static IP which is assigned should work if all faculties are on the same network. So probably that should work, sir. Yes, sir. Yes. So for today's session, what I done was like I created two virtual machines in Azure. These are like Windows virtual machines. And then what I done was like I made a two node cluster here. So one is called master, and another is called as worker. And if I connect to the master, so master is like here. um, so I have two nodes. I have installed Aneka on one master node, and then I added two machines. This is the master dot 04, and 05 is a worker node. And then what I done was like here, dot 4, I have one master, and one worker is running on 04. So basically, this will have two workers and one master. So this worker and this master is running on 0.4, and this worker is running on 0.5. So this is like just want to show you like programming some of the simple programming exercises, like how you can use and run using this task programming as discussed today. So yeah, so this is the Aneka setup which I have done. I think probably I had also explained about how to install Aneka daemon on the machine, and then how Aneka daemon sends all this information, and then in this machine, like how to create Aneka worker container and Aneka master container. So Aneka master and the worker container. And this master is responsible where you can assign what kind of scheduling algorithm you want for the master to do. So these are like things, like couple of things which we have already been done here. So considering this, uh, I will focus more on the some of the parts here. Uh, I think in your library maybe you will have this textbook called. Uh, I cannot share the PDF because it is not. Uh, uh, Good approach because PDF is not basically shared. It's for like personal use. But anyhow, like in even if you not give, if we will not share, then you definitely will also get online. But better to buy the hard copy. So in your lab, in your library, maybe you will have this. Probably you may having this book, Mastering Cloud Computing Foundations and Applications. So this is in this book. For example, I will just see. There are three sections. The first section will give you foundation to cloud computing, which is very nice, which talks about parallel computing, parallel architectures, SIMD, MIMD, those kind of parallel architectures, and how this kind of parallel or what is a simple threads. So this will talk about more specifically on the operating system and kernel level stuffs, and then parallel architectures. And here like virtualization, which talks about detail about virtualization, hypervisor, ISA, ABA, like, so all these things like are explained here quite well. And in the cloud computing architecture, this is general architecture of the cloud computing normal, since you have been teaching the cloud computing, so everybody has idea on this. And this part is like which I'm today is focusing on. uh, so here, so far, like what I discussed in the presentation on 14th of August, so everything is given in this. What is Aneka, architecture of Aneka, how Aneka is designed, what is Aneka kernel, what is daemon, what is the heartbeat service. So everything is like in detail. Given here. So even I also read from this book. So I advise you, if you have time, so then you can try to go through this part. And next is about these are like these three chapters are like programming models what Aneka supports, where Aneka applications can be developed. This concurrent programming, high throughput programming, and data intensive. So concurrent programming is using thread programming model. So where this kind of distributed Aneka threads can be used to develop this concurrent computing applications. Basically, parallelization, focusing on parallelization, how scalable and parallel threads can be used. That's a distributed threads can be used to develop the application. Next is about high throughput. In this throughput applications, we use Aneka task programming, where this high reliable tasks. For example, there should not be any failure while executing the task. So this can be how this kind of things can be developed. And next is a data intensive, which is kind of a map reduce uh, programming model. This is Aneka map reduce, which we will see maybe on the Wednesday part or something, like on Wednesday probably. So today I will focus more on this high throughput computing, where you can develop this kind of task based applications on the Aneka. Uh, so this is how, and here in the textbook, like each and every topic, like what is task, what is a bag of task, what is a job, what is the difference between task and job, and how these kind of distributed environments are used to deploy such kind of applications. Because many are of us in a research who we are doing research on the cloud computing or edge computing or fog computing, or even next further is the quantum computing. So our main focus is the optimizing this kind of scheduling or placement policies, not only based on some quality of service, scalability approaches, and these things. So understanding these basic things are much more important, so which are given in detail in this book. So I would recommend you to go through it. uh, so now let us see what is task programming and how Aneka is used to for the task programming, to develop these task applications. Basically, the question is like, what is a task? Any answers from the audience? Like, any, what is basically a task? For what I can say task?
Activity. It's kind of
Activity.
activity.
Very good. It's kind of an activity. Then
A small unit of work.
small unit of work. Very good. Then any computation, small computation. So all are describing about task. These are like characteristics of the task. In a simple example, if you answer like a shell script composing together execution of several application, very simple. Or maybe your simple Python program which takes two input and executes something. So task could be anything, either in complex image processing or any kind of application. So in simple terms, just simple program you can say, or unit of code, either it can be C++ or .NET or maybe a Java, anything. Just let me maximize this one. uh, yeah, so okay, streaming is quite less. Okay, so that is what we called as a task. Then there is a concept of called as a bag of tasks. What is a bag of tasks? Can we say a batch is a batch is called a bag of tasks? Yes. So it could be a batch, uh, a group of tasks which the computation logic could be same, but the output and input could be different. So such kind of distributed applications, probably we can consider them as an bag of tasks. So now, in this kind of structure, in a task computing scenario, why it is happening? Just let me. Yeah, this kind of scenario. So there is a bag of tasks, and this is a cluster, and in that cluster some nodes are like computing nodes which will process the tasks, and some nodes could be a storage or monitoring nodes or access nodes or whatever, and some nodes in that are designed for that to run the middleware, and middleware is the most important aspect in this kind of task computing scenario. So middleware responsibility is to submit, gather the output, and then the third part is like schedule, and schedule not only like coordinating the logic, if it is a dependency between many tasks, many task computing or workflows, in such kind of scenario, so middleware takes care of everything. So middleware is a core component in this kind of task computing scenario. So here, when I refer as a middleware, so referring middleware here in our case is our Aneka kernel could act as a middleware, and where users can use try to interact with Aneka middleware to submit this application. So now this is making a problem, I think. Yeah. So in the category of these task applications, we call them as high throughput computing. This high throughput computing comes under this task based kind of an application. But the question is, what is high throughput? What is a throughput here? Any ideas? What we call for throughput? How do we, number of tasks executed per second per minute, can we call it as a throughput? Work done per unit of time, definitely. So these high throughput means, when I say high throughput means all tasks given for the middleware all should be executed in this kind of distributed computing environment, since we say that like the computing environment could be heterogeneous, either cluster workstations or cloud machines, cloud infrastructure, what we can say, and these tasks can take a longer time than this performance computing. So I will take this performance computing tomorrow, where the threads are used. So high throughput is like these tasks can run longer in time, or some may run longer, some may run shorter, and there is a dependency between the tasks. One task may be dependent on other task. So these are all considered on the high throughput computing, and even some of the tasks may run considerably about the weeks or months in terms of, like, say for example, in science experiments. And so in that kind of scenario, we use this kind of task based programming. And there is another category which is comes under HTC, is many task computing. So many task computing means you have to run several tasks together, a bunch of tasks together, or bag of tasks together. So many task computing, in the many task computing, main the problem is this file handling, or file sharing, or data sharing between these tasks. So that is a main challenge in the many task computing. So we will not go depth by depth about all these frameworks that you can read, because to handle this kind of many task computing, high throughput computing, there are some open source frameworks based out of grid computing. Since the grids was like used around several years ago now, 2007 or 8, the grid was like top, people were using it to even 2006. So these are the like the grid computing frameworks, basically used for task computation, like Sun Grid Engine, Bion, Nimrod G, and then Condor. Aneka also was like on top of grids earlier, and then later it has been added some more components about scalability, billing, and those things, and then Aneka released as a cloud computing software. So you can go through this. I will not explain about all these tools or frameworks. So the motivation is today is to, or my main goal is that to only focus with the Aneka. Let me just go directly to the Aneka. Uh, yeah, sorry. Okay. So now let us see like how this kind of Aneka helps to develop such kind of Aneka task-based programming. Uh, in this Aneka task-based programming model, Aneka supports through, there is an API called as Aneka Task API. Let me just. I have a couple of PPTs, but these PPTs are more of text, which has created. If anybody is teaching, you need a PowerPoint presentations for teaching, so you can use the PPTs. From all the chapters will have the PPTs, and there is also diagrams section where you will see. I think this is not the diagram, but I will share if you need all the figures of all the from this textbook. It is useful for teaching. So this from here, maybe I will go with the textbook itself. I will not go through the PPT. Yeah. Just for a sake, I just want to refresh this, which is not rendering fast. So just let me refresh. Yeah. Still, I think it is a problem. So because I am not kept locally, I should have downloaded it. Yeah, now it's quite okay now. Yeah. So in this Aneka based task programming, as I shown earlier, the generic diagram, But here there are a couple of people are there involved in this. One is the membership catalog service, task scheduler, storage service, and task execution service. So what these four uh, core components will do: membership catalog is the person who will have the information about all the nodes, what task is going to execute, or like what task is currently executing, or what kind of data it holds, either it's stop condition, start condition. So everything the related to the task management is holds in the membership catalog. And he also provides the information to the task scheduler. If the task scheduler wants to schedule some task, then he will get the node information from the membership catalog. And storage service is a kind of remote FTP. For example, as I told, um, in a simple task programming, you know, don't need any kind of much storage service. But if it is a workflow or dependency, there is a lot of dependency between the tasks, then the remote FTP is needed, or you have to store data or certain on a network. Basically, Aneka supports either through FTP, or you can also store on Amazon AWS S3. And yeah, Aneka can render from or push or pull the data from the S3, Amazon S3. So task executors, this is basically the which they are executing this computation logic. The task, the what we defined, so that is going to be executed by these nodes. And what the at the other end is that developer will write directly through interface task, the what the logic of the task, and through this interface which constitute the task. And then when it is submitted to the manager holds these work units. These Aneka tasks are called as work units, and these work units are submitted to the here membership catalog is focused on mainly the master. And then there is a master, and along with this scheduler and master, like both are, like we can say, together. But this membership catalog will have the all the information about the for example, what kind of task ID, task node, task condition, so on. So this is the overall architecture of the Aneka task programming model scenario. So now, so when you want to develop a task programming model or a task application, then what exactly happens in the Aneka window? So first of all, you have to follow. It does some following list of operations. First is that what you have to do is you have to first of all write a logic what the task has to be done. Either it could be addition of two numbers, or calculating a Gaussian number or Gaussian series, or getting IP address of a machine, or detecting an object using YOLO of an image, or anything. Task could be anything. And then, so you have to write a logic. You have to write a logic for the what the task has to be done, that is through task interface. And then you have to add in a program where Aneka is, through this Aneka configuration file where Aneka is there. And then you also need to add this create this Aneka tasks and wrap it to the Aneka application, so that you can submit to this Aneka cluster. And lastly, what has to be done after execution, and what if the task fails, then what to do. So these kind of event handling mechanisms also can be written. For example, say you have 10 tasks, and after completing all the 10 tasks, you need to do something else, then that is called as application finished. So when all the application is finished, then what to do? When the task unit is finished, then what to do? When task unit is failed, then what to do? So that we will see in the program, like how you can write them in the Aneka. So this Aneka interface, that where you are going to write this Aneka tasks, it comes under library called Aneka tasks.dll. So this will take care of about this one. For example, in the last exercises in where I shown you, in the thread model. Anyhow, tomorrow I am going to show you. So here, this is the library which is responsible for this Aneka task interface. So let us see like what is an Aneka interface task does. Is that you when you define this interface, Aneka tie interface, and then it has a method called execute. So what is this method execute? Execute in this method itself, like you have to write what to be done, getting an IP address or getting what is the any task. So that is the user logic, like as a developer, what you want to write. So this you can able to write. So this is like how the iTask interface is written. For example, I will show you here. This is one program which is written to get IP address of the machine, host name and IP address of the machine. For example, I written iTask. I have given some XYZ as a class name, and then there is a task interface, and then these are the variables. These are the variables for your logic. Whatever you need, you can declare them. And here is the method which I written, which is called execute. So when I open this, and here is the logic which will try to get the IP address of the particular machine where the task is executed. So there the IP addresses, host name and IP addresses are gathered. Okay, so this is how the task is written through this interface. Next is like how to control this task execution. Means that controlling the task execution means these tasks can be statically submitted, or tasks can be dynamically executed. So what is mean by static or the dynamic? And then is one is that how do you control the tasks submission. The other thing is how you can monitor the application state and task state, meaning that either or the application is finished or failed or running or what it is. The similarly for the task, because this application has a set of tasks. So, and these tasks can be controlled statically and dynamically. What is mean by static? Static indicates that, like say, this is one of the static what I shown here. Here I don't control the tasks what is happening. I just tell that create a task. Okay, this is the task you have to run. But what is a dynamic task is that if the task is finished, then output of that task, I can just take that output of the task and provide as the input to the another task. So here, like the input and output is controlled. So that is what we called as task, the static and the dynamic submission. And then event-based notification means that if the task which is executing, maybe it is not getting the data what it is needed, and hence that is failed, that task is failed. So then there should be some event which should be generated, so the task is failed. And you can write one logic. What is that logic? When the task is failed, what to do? When task is completed, what to do? So these kind of event notifications are handled in the Aneka. And Aneka application basically has this pattern. There is a Aneka task and Aneka task manager. So Aneka task is the task which you defined there, okay, and Aneka task manager who will control that the set of tasks or the work units. And coming here, so here you can say this is Aneka tasks which are created using this task interface, okay, and each task in Aneka normally they called as a work units. Okay, we call them as a tasks as a work units, and each work unit has can require some input files, and also it can have the output file. And these input and output files are shared or local, or can be shared in a remotely through FTP or Windows file share, or maybe through Amazon S3 or whatever. So this is a code snippet, which the logic here is to calculate a Gaussian series for a particular number. So that is one task that has to be executed. And here the logic of the task is written here. So you will give the one series value, what is the maximum the series value to be calculated. And this logic, this task is created, and what is the business logic of this task is to calculate the Gaussian value, Gaussian series value up to certain number. And the most important thing in this writing is that you have to write, or you can put a serializable here. The what is the meaning of the serializable is that, like, serializable, because normally when you run or execute these tasks, task run on the network, over the network. So serializable, which will try to encapsulate this data, means like, not I could not say, it's wrong actually to say encapsulate. It's like, this data has to be encrypted, not encrypted. The controlling of the data over the network is automatically taken care by this .NET environment. So that is like serializable. If I see what is the code snippet 7.2, let me just see. I think there is a separate section on the serializability, which I will talk in detail later. Here it is not there. Okay. So this is where the now we are writing the task interface. So like similarly, like here. So what we written, the same logic here to calculate the Gauss. Next is about, so what is next? Next is about, like, say for example, I written the logic what to do. Now I will create object of that class, and then I will create Aneka tasks of that interface, the logic what we have written. And then if you want to provide an input file for this task, you can add the input file. And if you want to store the output at one another location, like say you can designate with the input and the output. And for the input txt, you can give what is the input needed for that business logic. And either what is this, either this file is locally residing, or it is at some store, some ftp, or some remote store, or where that the configuration file is about. And by assigning like this kind of uh, input and output, it is easier to deal with this kind of, if we have large text to provide to the, or if you have large, like say megabytes, or maybe some kind of kilobytes of data, or something image file you want to share to the task. So in this scenario, this kind of assigning this file input or output locations are useful. Let me just go to 7.3. uh, yeah, so this is a 7.3, that what I explained. So input files and output files are there, and each work unit class are assigned with the input and output. And these output files can be collected from execution node, or moved to the local machine, or to the remote ftp. And you need not to care, as a developer, you need not to care about how this is shared, how this Aneka will move the data from developer machine into the master machine, and then from master into the worker node. So you need not to worry. So Aneka will take care about. But the only thing is that if you are providing remote ftp, then you should give the proper address of the remote server and everything in the configuration file. That we will see. Okay, so that is about, you written a logic, and then you created some kind of tasks. Just this is just a sample code snippet. Then this is a single task that you created here. So this is a single task which you created. For example, you have a bag of tasks. Say for example, you have 400 tasks that you want to create. So this code snippet will tell you how to create a multiple tasks. Um, the other part is that, like, in when you write an Aneka application, so let me just go here and tell you. Let me okay. So in Aneka application, first of all, when you create Aneka application, so Aneka, each whatever, like in C Sharp .NET, when you create a console application, the first thing is that you will have a main statement, and then the Aneka, when you create Aneka application, the first thing is that you have to import the configuration file. So the configuration file which I shown to you, mm, which has this scheduler address and then QoS, so that this is the where like you are going to this will import the configuration file, and then some of the attributes in the configuration file you can access. For example, here when I say edit, so like for example, these are the attributes, like say single submission, resubmit mode, polling time. I will say what is this, I will discuss about what is single submission and these things. So these attributes you can easily access through the in your program. So once you read this configuration file, then you can specifically see that okay, single submission is either equal to true or false, true or false. So you can set the variables through program itself. And if you have stored a remote, your Aneka has to use the remote file transfer, then you have to say conf.user file transfer equal to true or false, and so on. So this will give you greater advantage for the developers, that you can assign from the program itself. And but if you make it true, then in the configuration file, so here somewhere here you have to provide this the address of the remote file, remote FTP server or S3 or so on. So that we will see in the further. uh, okay, so these are the things which will make your configuration ready, this configuration ready. So similarly, as I did here in the textbook, where is that? Okay, so here, so this will make take your configuration get ready. Okay, single submission is equal to true. Let's see that what is this single submission is. uh, Single submission means when you submit your application, if that application has a task or the work units, if all the work units are executed or some of the work units are failed, whatever it happen maybe, then Aneka will not resubmit the failed task. So Aneka will just come up with whatever so far what is executed, it will just display the result. So if you say that there is a conf.resubmit, resubmit, then you can just resubmit the failed task until that task is get executed. So this single submission will take care just for a single submission of an application. Okay, so now here this statement will helpful for, or this is the main syntax for creating Aneka task application. So just let me go to the code. So here first here I declared the Aneka application. So I just created that okay app of which has the, this is Aneka task and Aneka task manager application, and this app is equal to Aneka application. And then what I do is I will attach this configuration file and I will give one name for my application. This will like either you can give or either you cannot, like it depends on you. So if you remove that, that's also fine. So this is just a Aneka application, and each application may have a work units or Aneka tasks. Where is my, okay. And now here what they have done was like this, they have written one logic. What is that? Is that like it has to execute 400 tasks, 400 tasks, and each task, each task they will give the value, something like this is this logic is to calculate the Gauss value, and the X value is based on the change of the input. So the input is the I value, and that will give the series X value, so that they try to calculate. So this basically what that logic is here is to create 400 work units, and we will add them into the application. App dot add work unit of what is the task. Task is to calculate the Gaussian value, And where we return that logic, the logic is here. So the logic is here. Go sample I task. So this is the logic. So and now, so now we have in this app 400 work units. Okay. Now next thing is that we have to submit them. So submitting is app dot submit execution. So which will submit all the 400 work units into the Aneka master. This is about like how you can devise the multiple task or many task computing. Uh, in my example, I don't have 400 tasks, but I have only single task to perform. So what is that task? In my case, the task is to get the IP address. My task is to get the IP address. So let us see like how let us proceed like how we can run this application and see what are the other characteristics. So this is what is called as a static submission. So I'm not dealing either task is failed or either task is executed or so I'm not bothered about it. Just I will try to submit this application. Um, Next, so what is mean by the dynamic submission? So dynamic submission has something extra. What we call is like event handlers or event notifications or event notifiers. So what those are event notifiers that are like work unit failed and work unit completed. Means I am submitting 400 work units. In that, how many work units are if that work unit is in any work unit failed, then you have to control it, and then if it is completed, what to do. Okay, so this is how like these events are handled. So now let us extend this code 7.4 about how the dynamic task submission strategy can be applied for this execution of the 400 Gaussian tasks. So this is the is it really visible for you because it has a multiple colors? uh, yes sir, okay. So let us see how this is used for the dynamic submission. So in dynamic submission, okay, just a minute. Yeah, so this is a dynamic submission. So in that we have to write extend that to control the logic, controlling logic or event notification logic. So as we see in that, we have to write two extra methods here. So one is what if that work unit is failed, and what happens if the work unit is completed. So here the one is that what happens if the work unit is failed. So if that work unit, whatever it is executed here, it is failed, then you have to do something. So here we are not going to do anything in this logic. Just what they want to do is that if that work unit is failed, and then just display that work unit name, and then say that what is the error message that it is getting. So that is this on the work unit failed. What is the work unit failed? So in that approach, and most importantly in dynamic submission, the single submission strategy should be false, because in you may write if that work unit is failed, then you may tell them to re-execute or re-execute. So in that time, this single submission is equal to, you have to make it as a false. And in this you are writing two methods, as I told. One is what work unit failed, another is work unit finished. So work unit failed, the method which you have written here to display the error message, and the other one is the work unit finished, which is like if that work unit is finished, then what to do. So these two methods you extra added here. For example, in my code, if you see here, so here app dot work unit finished, I added an event handler, and what is the method here? So method work unit finished means it will come here. So here I had written a method. So what happens in work unit finished? Work unit finished means just to display the output, what it is done. what the task has done. Task has given me host name and task has given me IP address. So what I do is like I take the work unit arguments as a test, and then I try to get call the methods, get executor node, and then get because in this task I have written already what is the logic. Say for example here, get executor node and get IP node. So here this will get the host name and the IP address, right? So here uh, executor is the host name, and then get IP node is the result is the IP address. So just I want to gather that information, what that logic has been executed. So here in the work unit finished, I just want to display them on the console. So that is my goal. So here in this case, since it is a 400 task you are going to run, okay, and you have written two methods here, but I could see only one method, so one method is later they have written. So here this will doesn't they just, it will display the error message. In my case what it does, work unit failed, nothing, just I will say that console print what is the error message. I can write this console.println and then say that okay, what is the error is going to happen. That is the logic, that what you can write. You can write your own logic. So once this dynamic submission, I will also talk about this work unit finished. What they have written here in this code is that in this, if the work unit is finished, if the task is completed for sure, then we have work unit instance and we do not need to check as we did before. So we don't, because it's already been executed. And he written some logic. What this logic he does is that like he just see that the input, whatever the output what is got, then again he want to submit that give that input as an input to that function. So and again recalculate the Gaussian. So that is what the logic is written here. You can later you can go through this logic. So this is how, just I want to say discuss about the methods and then the logic what you can write. So in my case, so I have written both of the methods, finished and then failed. So let's go to the next part. These are like a very simple non-dependency kind of tasks, and you can also set the file management properties for your tasks. What could be your input file, what could be the output file, where the file has to be stored, and the in this kind of like say dependency or workflow kind of environment, managing the synchronization between the tasks are quite difficult, because like how do you check is that task okay, anyhow we have the events, but the sequence of events you want to execute, okay ये पहला task है, उसके बाद second task वो है, third task वो है. So this managing is quite that developer has to take control over that, and you have to write it. For example, like say either uh, just I want to show here. Yeah, so in case of, for example, in the static and dynamic submission, I told that a single submission is set to true. So means the runtime means Aneka kernel will automatically determine the completion of the application. But if you say that single submission is equal to false, then developer has to write your own logic. So how do you what is that logic? That logic is that when to stop the application, because application will not stop here if you set the single submission is equal to false. So you have to write logic when the application has to stop. So in this case, Gaussian execution of 400 tasks, it has to stop when all 400 tasks has to be executed. So that you have to write. So here you can see that somewhere it is given that the what is the stop logic has to be written. So yeah, I think we will go to the 7.6. Yeah, so here, yeah, so let me just go through this. So this is a complete code of that. Just I will go through the code and then I will run my code. So yeah, so this is a configuration file. When you write any Aneka application, the first and foremost thing is that you have to write the task interface. So I think here the task interface is not written because they are referring from the previous one. Yeah, so here is the main, and once you return task interface, then the main statement, then here you will give the configuration file. It tells about your QoS and then configuration scheduler URI and so many things. And then you will submit the application with respect to that, attaching that configuration file. And here yeah, so just let me, yeah, so here what he is doing is, if that the single submission is false, then you have to control your application when the application has to stop. So for that, what he is doing is, like, he is giving the count. He is declaring a variable called, like, say 400. And if all the whenever the task is executed, just he decrements that value, and when it comes to 0, then you should say that, okay, the application has been finished. So I think probably here the logic is written. So let it's very difficult for me to mouse over on this code. So here, like, it will check if the task count is 000, then it will say that app execution should be stopped. And whenever the task is executed, I think he should decrement. So here what he is doing, he is incrementing the value here, because 0, 1, 2, 3, like that, if the as soon as the tasks are executed, so he will increment here task count. But if it is failed, then he will decrement that. So from here, task count minus minus. So like that, he can able to control this application execution, that all the tasks and dependency of the task. There are some, like, workflow execution examples are there, which the codes I will share to you, how this one task and other task, if they are related, then how you are going to run such kind of things. Let me run my example, what so far we done. So what we have is that we have written the task interface to get this IP address, and then we have a main method, okay, and all this, and so failed method, finished method, okay. So, and what I have is, I have my configuration file stored somewhere here. Let me open that. So this is my configuration file. So what I done was, like, here, if you see, I have given the IP address of my machine, my master machine, 20.107.246. Because I have to give a public IP here, because from my laptop, from my university network, so I have to submit to the Aneka, which is configured on Azure cloud. So I am in my university network. Now if you go to the my virtual machine, and if you see my public IP, so this is my master public IP. And where is my master? So master is this one. You can see the TCP colon 10.0.0.49090 Aneka. So here this IP is replaced with the public IP in my case. So it will directly done the address resolution from public to private. So now network address translation, so NATing. So here I have given the public IP address. In my case is here, and so application is here, that I added that configuration file. And let's try to see. So what is the output of this? What I want to get is that When application is finished, so I want to print the IP address and the host name. Of the work unit will print this one, but at last when application, the final application is finished, so I have to get application ID, submission time, completion time, scheduling time, and this so on. So let us see. So now what it says is that I have got the output from cloud saying that the application ID is let me zoom in, large, no, cursor size, oh sorry, font is something like 24. So now you can see that it said that it's executed on the host master, because in master itself, in the host also, in the master itself we have one worker. Application is finished, and this is the application ID. Let us see that either this is executed on the cloud or not, in Aneka Cloud hosted on Azure or not. So this application ID is DA2, something like we remember, and let us check there. So let's go here, go to the tools section and use reporting and statistics, and then connect to the cloud. Then now I want to know about the applications. Uh, so what it is executed. So here DA2, if you see that is executed, say it says the status is done, and this is a task 1, submission time, scheduling time, and where it is executed, let's see. So it is only executed on the master at 9092. So it is executed, so single node. Yeah. So let's say 38. It doesn't use much any CPU utilization, just it's like 0.1 or 0.2 percent, which is less than 1%, even not less than 0.5%, means that it's just a simple, very simple tasks, which has like nothing to not any complex task it is. So like that you can also try to mm, run very simple tasks. So this is that one, to get the IP address here, that is just very simple, which I written something like some programming like try to find out Fourier transform series, or finding sine of x plus cos of x plus tan of x equal to something. This is just a very simple one, but in considering this kind of, if you want to develop application, then what you can do is like, for example, YOLO detection. I have written one logic I can show for how this YOLO task is written. Let me just see the code where it is. YOLO. Long back I have written this YOLO Apache Life for Aneka materials. Yeah, something here. YOLO Aneka. Open the path. Aneka. YOLO tasks. Okay. Is it here? Just a minute, I will. Aneka client. Where is this code? Code is not here. Maybe I will write open this. Just let me open the code. Code it is not here. Yeah, the code is here. No, this is also not here. Then here something. Yes. Oh, solution is not found. So here it is. So I will tell you, like, give an example of YOLO and then how it can be used in research. Something like one of our fellow member has written one article. I will show you that article associated with this Aneka task programming. So here, what is happening is, so in every case, like I had to write one task interface, and this is all developers. It's left to developer, like how you want to write methods here. But the one compulsory method is the execute. This is execute, which is Aneka has to Aneka takes care. If you doesn't return any execute method, then you will get an error. For example, like say, if I hide this method, or if I comment this method, then definitely you will get an error message. So what, because this execute is inherently like Aneka wants, when the task is executed, it should need this execute method. So in this case is the YOLO. So in the YOLO, what is going to happen is that in every worker node, either you can install or you can put this Windows YOLO versions in all the worker nodes, or else you can tell the master to say that, okay, this is the location of the YOLO framework, and then to that YOLO framework, so you are giving an input. Input is the image. Okay, so you should give the input. Input is the image, and then where the output has to be stored. So where the output means, like the input it will take, and it will see, it should give me the output. Output is like what are the objects from that, what are the objects from that image, either it is a dog or cat or multiple people or something like that. So this is one task. So here, most importantly, I have to share the data from my developer machine. I have to tell that where is the data is coming, and then where the output has to be stored. So I have to tell that, and then what is the command to execute is here. The command is to execute that detect. Detect is like the path of the where is the YOLO, and then this is just a command for the YOLO. If you go to the YOLO documentation, then it will tell how to run this in on Windows machine. So this is how. And when as a developer, you can build and deploy this application, and continuously you can send images to the Aneka for this application, and it will continuously submit it to the Aneka, and then the response will, you will get either it is a cat dog, like that. And the one good application of which this type of application is used by one of my colleague is, he written one article. Let me just show you. Excellence. So he written one very simple article based on this very simple application. Even you can also take this as one project. In the I have written what to do in this project. I will share you this one here. Did I written? No, I will add this project 6, distributed or YOLO object detection using Aneka on streaming image data. So this is one simple project students can do. So let us see like how he has done. This is like deep learning object detection on integrated IoT edge and fog. If you see the architecture here, this is very simple. So the underlying working principle is same. So I have explained the code here, right? This is the code, and what he is doing is here, he is taking something like a picture from a camera, or video camera or surveillance camera, and it is through Bluetooth it will send that streams to the mobile phone. Mobile phone will act as a gateway, and from the mobile phone, those tasks are submitted to the Aneka master. So this can be, you can consider as a edge cloud. Edge cloud means in his lab only what he done is he configured, like in MIT ADT you have the couple of machines, right? So like that he configured cloud here, and he also done hybrid cloud, where he took some Azure machines and Windows machines and he connected to that. So it's kind of a multi-cloud environment. So he configured, and then this gateway device will continuously stream the data to the Aneka master. So whatever image comes in, he is using only images now. As of now, he's not using any kind of video streams. But you can extend this. What happens if the video streams are coming? Then extract particular frame from that video, based on frame per second, and then you can process it on the Aneka. Okay, and then you can try some scheduling algorithms here. What happens if the image size is too large? Then send to the cloud. If the image size is less than certain limit, then run on the, because edge clouds are very resource constraint devices, or resource constraints you can say. So like that you can write your own scheduling as a part of research if you want to extend this. And overall the theme is that simple kind of object or video processing application, streaming means the images are coming continuously. So that kind of applications you can able to write. And if you see that here, he just done some experiments. Just he took a photo of sandwich, and then sent to the Aneka will tell either it is a sandwich or what it is. And similarly, like he took some photos from the lab, from the camera, then it will say monitor, TV, keyboard, something, so on, these objects. And he tried to find out the accuracy, low latency, how to from the edge to the cloud, how much network transmission it took, and so upon. I wonder what is the time, how many frames per minute it is, the stream is coming, and so on. So like this, it's a very simple comparison of the article. It's done, and it's accepted for good conference, I think. It's published in a conference. So this is how you can utilize this, what I would say, this task programming example, task programming, Aneka task programming. Like that you can write some more complex applications. Not only this one, you can write more complex if you have a workflow, like one output of one task is dependent on another task, so on, like that. So if it there, in that case, like you can write. So from this, I will talk more about this file transfer, data transfer in the next class. Like how to you can give the input file, output file, and these things, like, and how to coordinate the logic, like say for example, how to give the text file, and so on. So I will talk in the further class. So what I expect is that from you, because so far I have discussed a lot. So try to run. I have given a source code of all this in the, while I told, I have given you during my lecture. Try to run this IP address application on your Aneka clouds residing in your campus, Aneka in MIT ADT, and then run this GAUS application. GAUS code is also available there. Run this GAUS 400 task code. If you doesn't have that code, you can take from this textbook, or the code is already there. It is stored in the examples or tutorial section, so the code is there. So run this, understand how this Aneka task works, and then we will look further. Like we will write our own applications, which you can give to your students. I have this couple of use cases which we need it, and each topic will lead to one publication. If seriously, if the students and our supervision works, then each will lead to good publication. Not very simple. And if we finish any of very good publication, then it would nice to submit for this conference, A Star conference 2024. is that? So this is an A-star conference, and we would see some papers from these topics if everything goes well. But it's very hard to come with this deadline because paper submission is in December, I think November 27th, but it will be extended to December 15th. So we have around 3.5, 4 months. If everything goes well, then I can help in the writing part and also some supervision part if needed. So I want you to try out these examples if you have some time. I don't know either you will have a time or not, like say, but it would nice, not now but tomorrow, you can try it out. And next, now further 15 minutes or like another 20 minutes, I will just try to discuss with you if you have any doubts, or else like you can go to the lab and try out these examples. And also one more thing, I want to open a channel, either could be Slack, but Slack is which communication channel where you can, if you have any difficulties or struggles, you can put a message on this channel. Maybe I will create on a Slack on channel, and I will share the link to you. Share the link, and if you have any questions, anything, you can just put, then I can reply to that. This is all for today. If you have any questions, then let me answer your questions.
Hello, sir.
Yes, madam.
Yes, sir. I hope session is over now.
Yes, madam.
Mm.
So now what I